My name is Vladimir. Glad to see all of you here. At Lyft, I work in client architecture, where I work on Dagger to support lint rules and other, boring stuff. Today we will talk about what's wrong with KAPT and how we can avoid using it in case when you really hate it. So, what are the main problems of KAPT? First, it increases build time. Without it, we're required to write a lot of code that we could avoid in other cases, also called boilerplate. It requires us to do additional setup in our build pipeline and brings flakiness that needs to be solved at build pipeline level 2. Let's quickly talk about these three problems. Build time. As Uber's research showed us, Kotlin with KAPT adds like 95% overhead when compared with pure Kotlin compilation. And Java APT adds only 5%. Worth thinking before adding it. Second problem. Without a hope to use annotation in Kotlin code, we are required to write a lot of boilerplate, which is often blamed on Dagger 2. On this slide, you can see the constructor injected class with a bunch of constructor parameters and Dagger 2 module required to add this class to DI graph. No one wants to write this Dagger module and mess with hundreds of modules like this. The third problem is related to your build process or communication with your infra team. Sometimes it's hard even to convince them to add more time and resource-consuming steps to your build pipeline. Alas, even if you will be able to do it, or if you are the infra team, you could get certain problems with flakiness and support of usage of KAPT, especially in multi-module project. So originally, I only planned to speak like 2-3 minutes, but to make it longer, let's talk about how does KAPT works. When you add KAPT to your build, your regular compilation steps from simple compile Kotlin, then compile Java, explode into this. First of all, KAPT doesn't do any annotation processing by itself. It generates Java stubs and feeds them to Java compiler along with Java sources to do the actual annotation processing. This has its own reasons. For example, it allows Kotlin to see generated code at the moment of compilation. So let's look at the stub generation process. What is a stub? Look at this Kotlin class. It has annotated constructor, function, and field. Also notice the non-annotated private field. Let's look what kind of stub will be created from this class. The stub is a regular Java class, but without any code inside its methods, except those required for compilation. Pay attention to the private hahaha field. Although it is not a public API of the original class, it's still generated. Okay, could it get worse? Yes, stubs are generated even for classes without any annotations. So for any classes, even if they don't require it for annotation processing. I don't rebuke anyone. I understand the reasons lying behind those decisions. But anyway, all this code generation before code generation definitely takes time. And how much? I'm not sure. Who am I to judge? Could we live without stubs generation? Let's try it. Let's try to avoid stub generation completely. Okay, how to get maximum without enabling KAPT? Look at this internal class. Could this class be used in Dagger 2 graph without enabling KAPT? The answer is yes. If we have a component like this written in Java, we are able to use KKK class written in Kotlin without KAPT. But what happens if we rewrite component to Kotlin 2? The rewritten component will not work without KAPT. Why? That happens because Java-C doesn't know that we have component annotation in our compiled Kotlin code. Okay, but why the same doesn't apply to inject annotation? It happens because component annotation is an entry point for Dagger's processor, and if Dagger finds some unknown type with inject annotation on constructor, it could generate required factories for it and use them. So, for example, technically, it's possible to automatically add types with injected constructors from external dependencies to our graph. But Houston, we have a problem here. If a class with an injected constructor will be used in Dagger components from different build system modules, APT will generate a factory for it in every module where this dependency is used. And these factories will clash at compile time because they have the same fully qualified class name. So Java compiler processes source files and classes or class files. What if Java annotation processing could process class files from dependencies too? And apparently it can. A few months ago, I found this unknown, at least for me, section of Java C documentation. It allows us to ask Java C to add certain classes to its annotation processing path, even if these classes come from external dependency like external jars or comes as a folder with compiled classes. I was very excited and immediately asked our infra team to use it, but they say that it's really, really hard to alter our invocation of Java C or whatever they use to compile Java code. I wasn't sure, actually. If you know how to do it by yourself, you can just ignore the next slide. To solve this, we found an easier but hacky way to achieve the desired behavior. We wrote a Java C plugin that looks for Kotlin classes, compiled by Kotlin C in the class path, and setting them to the internals of Java C. Basically doing the same thing as we could do by passing right parameters directly to Java C. So right now, our setup from the previous slide starts working. Let's talk about the drawbacks of this solution. As I said before, without KAPT, you can't reference generated code from Kotlin because Kotlin C knows nothing about it at compile time and can't see it. But we can hack it. Since Dagger only exposes static methods as entry points for creating components, we can simply bridge calls like this through the Java static methods, as you can see on the right side. And we can safely call those methods in Kotlin. So the question is how to reference generated type in Kotlin, and I don't know, because in our project we don't need it, and we didn't investigate it, sorry. But if you know how to do it, please let me know. I'll be glad to see it. So wrapping up, here's the compatibility table between Java APT, Kotlin APT, and NAPT. If you think your project falls into NAPT category, we encourage you to try NAPT and experience faster builds. Definitely share your feedback with us. We plan to open source it. Follow us on Twitter to get notified about release. Thank you. Feel free to contact me with any questions.